In this video, I want to prove the third isomorphism theorem for rings. In the last video, we looked at the statement of this theorem, and we came up with a strategy for trying to prove the theorem, and I want to start with that strategy. In the last video, we decided that we could use the first isomorphism theorem to prove the third isomorphism theorem by finding a ring homomorphism pi that takes R to our target ring of R mod I modded out by S mod I, such that first of all, pi needs to be onto the target ring, and second of all, the kernel of pi needs to be equal to S. Because if I have those hypotheses satisfied, then the first isomorphism theorem kicks in, and the first isomorphism theorem says that R mod the kernel of pi, so that would be R mod S, will be isomorphic to the target ring, which is R mod I modded out by S mod I. Now, we even had a strategy for finding pi at the end of our last video. We decided that we could try an obvious map. We could let pi of R simply be R plus I plus S mod I and see if this works, because this is for each R inside the ring R, and this particular element is inside our target ring because R plus I is an element of R mod I, and S mod I is the ideal that we're modding out by. Inside the ring R mod I modded out by S mod I. So this particular guy is indeed in the target ring. Of course, the questions that we have to answer are, is pi a ring homomorphism? And is pi onto our target ring? And finally, is the kernel of pi actually equal to the ideal S? So those questions have to be answered. If all answers are yes, then the first isomorphism theorem says we're done. So what we want to do in this video is address these questions. So let's first of all turn our attention to whether or not pi is a ring homomorphism. So is pi of R equal to R plus I plus S mod I a ring homomorphism? Well, let's think about showing that. So first of all, pi preserves addition. So let's look at pi of R1 plus R2. Well, by the definition of pi, that would be R1 plus R2 plus I plus S mod I. Of course, it's important to realize that this plus sign is in R mod I. And I know how R1 plus R2 plus I works in the ring R mod I. This particular element of R mod I is in fact R1 plus I plus R2 plus I. And so we have that element plus S mod I. And this is because R mod I is a quotient ring. But we also know that R mod I modded by S mod I is a quotient ring. And this is the sum of two elements in R mod I plus the ideal that we are modding out by. So we can rewrite this stuff up here as R1 plus I plus S mod I plus R2 plus I plus S mod I. And this is because R mod I modded out by S mod I is a quotient ring. And now it's all over but the shouting. The stuff that's right here is nothing more than pi of R1. And the stuff that's right here is pi of R2. And so what we do know is that pi preserves addition. So now what we have to do is turn our attention to whether or not pi preserves multiplication. Well, let's see what pi of R1 times R2 does. By the definition of pi, that's going to be R1, R2 plus I plus the ideal S mod I. But this particular element is inside R mod I, and so R1 times R2 plus I is known to be R1 plus I times R2 plus I, and then we want to add the ideal S mod I to that element in order to stay in our target ring. So going from here to here is because R mod I is a quotient ring. But now what I want to notice is that this is now a product of two things in R mod I plus the ideal that we're modding out by in order to get into R mod I modded by S mod I. And so we can break this up into R1 plus I plus S mod I times R2 plus I plus S mod I. And this is because R mod I modded by S mod I is a quotient ring. We looked at this arithmetic in the previous video, and so if you're a little bit concerned about the arithmetic, I would encourage you to rewatch that video. And at this point, we realize that this is nothing more than pi of R1, and the other one is pi of R2. So we do have that pi of R1, R2 is equal to pi of R1 times pi of R2. And what that means is that pi preserves multiplication as well. And hence, pi is a ring homomorphism from ring R to R mod I modded out by S mod I. In the next video, we will look at whether or not R is onto, and we will look at the kernel of, we will look at whether or not pi is onto, and we will find the kernel of pi.